Miscellaneous electricity lab. It wants me to create this circuit, which I have, 2 batteries, 2 light bulbs, and a switch. And notice that this is the positive side of the battery, just like that's the positive side of the battery going that direction, and they're going the same direction. Now it says, put in a second switch. I was going to use a wire, but since it says second switch, I'm just going to put it here. Let me make this look as identical to the diagram as I can. There we go. So I turn it on, both light bulbs come on. Okay, what happens when I close the second switch? First bulb, let me go ahead and turn this off. The first bulb goes off, the second gets bright. Okay, so when this is closed, this goes off and this gets brighter. Okay, we all see that okay? All right, then it says when the second switch is closed, when the second switch is closed, which has more resistance, the light bulb or the second switch? The light bulb. When it's open, the second switch. When it's closed, the light bulb has more resistance because the second switch, when it's closed, is just a wire, okay? So why does the light bulb turn off when the switch is closed? And really it comes down to this. Electricity takes the path of least resistance, which is the second switch. Let's look at this a little bit quicker, or a little bit more in detail. Now it doesn't have to be a switch, okay? It could have used just a wire, okay? And notice again. So, and what does that look like? That looks like if I were to, actually I can even just do this. I can go from this point all the way over there. Now it's the equivalent of 2 batteries and 1 light bulb, okay? Now, short circuits can be problematic. They can be even dangerous. You've heard people say be careful of a short circuit. The other day when I took this whole kit home, one of the battery holders, the 2 ends of the battery holders connected and it made a short circuit. By the time I got it home, the battery was very, very hot. And in walls and so forth, if part of it gets very hot, it can get hot enough that it can melt insulation or even cause a fire. So a short circuit is a dangerous thing. Now, if you look over at this, I'm sorry, I could have done, for instance, if I did that as a short circuit, as just a wire, the electricity would go through here and it would go past this light bulb, okay? Because electricity will always take the path of least resistance. Now the next one talks about variable resistors or potentiometers, okay, also known as rheostats. Make the following circuit: 2 batteries, a switch, a light bulb, and a variable resistor, which for us is this dial. Go ahead and take out one of the light bulbs, and I'm going to put in this thing right here. I don't need to connect those, but boom, boom, and hopefully this one works okay. So I'm going to put this at, actually we're just going to explore a little bit. So there, oh, I don't see anything. Oh, lights on. Oh, see what's going on. Okay, so let's go ahead and answer some questions here. Adjust the variable resistor both directions. What happens? The bulb dims and brightens, right? Okay. When does the variable resistor have little resistance? Think about that. When the bulb is bright. When does variable resistor have a lot of resistance? When bulb is dim and actually off. 2 examples of variable resistors in your house. Think about that for a second. Again, watching here. So right now there's very little resistance here, and it should be at, oh yep, it says 0. So now as I go up a little bit, notice it dims very, very quickly. That's a lot of resistance for such as, that's very little resistance, and this is a lot of resistance. And as we saw in the series circuit lab, if this is a big resistor, it takes all the voltage and there's nothing for that light bulb. Okay, so now let's talk about examples of variable resistors in your house. If you don't have, some of them you may be incorrect, but let's just, the easiest ones are your stove, the dials on the stove, stove dials, a dimmer switch on a light. Or if you have a variable speed, like a dial that you can turn up and down how fast your ceiling fan works. Now on old style radios, they used to have switches like, or they used to have dials and so forth. That was not actually a variable resistor, it was a variable capacitor. But in a lot of cases, you know, there you go. So now, next one, diodes. Make the circuit. I want just 2 batteries, a light bulb, and a switch. Get rid of this. Put a wire in here. If I can get it to reach, let me use the larger wire. All right, make sure everything is working. There you go. Okay. By the way, excuse me, if I were to put a wire from here to here, it would just make a short circuit for the batteries, and that would be very, very bad, right? So again, always be careful that when you have conductors and so forth, that you don't bypass the resistor in the circuit. So make the circuit, reverse the light bulb, turn it around the circuit. We did that in the first lab, but let's just double check. Okay, if I turn it around, the light still works. So you can see that I'm actually turning it around. There you go, no problems. What happens to the light? Nothing. What does direction matter with a light bulb? No. Call that omnidirectional. Then place a diode across the open switch. Okay. So let me go ahead and get a diode. All right, I'm back. Back in the New York groove. You may not believe who that is that sang that. That was actually Kiss. Weird, huh? Anyway, sorry. So right here, let me see if I can get that up close enough. That's a diode. Okay, I'm not sure if you can see that very, very well or not. And it has a little bitty silver piece on one side of it. Okay, I'm gonna have to put a picture in here. So I'm gonna put this on the switch. All right. By the way, the little silver part is on that side. I'm gonna turn it around. And the light bulb comes on. The silver's on that side once again. Nothing. Make sure that's connecting. It's connected. This side. Light comes on. Interesting. So, reverse the diode, record what happens. So, the light comes on, only one direction. Just not my favorite group. Okay, sorry. Record what happens. What direction, does direction matter with a diode? Yes. Look very closely and see if you can figure out which way is the correct way to put it into the circuit. Okay. Now, again, maybe I can zoom in on this real quick. Okay. Can you see that little silver piece there? Right there, see that little silver end? Okay. That's the direction the electricity should go. The electricity goes that direction from positive to negative. So that's why, all right, again, when I put it this way, electricity will flow, and if not, it doesn't work. Okay. Pause so I can, and by the way, there also are LEDs, which are light emitting diodes, and I have one here, and I'm going to bet that this does not turn on. Let's find out. Matter of fact, let's turn it around. So obviously if it's an LED, oh no, it did come on. There you go. This one did not come on, however, and we'll talk about that later on. This actually takes up most of the voltage, and that one doesn't come on. But notice it only came on one direction because it's an LED. All right. Now in this case, it's hard to see. You kind of have to see, oh yeah, one side is longer than the other. So notice this side is longer, and that's the positive side. There you go. Now this last one is a demo for alternating current versus direct current. I've got it right here. See if we can set it up for you quickly. I'll be right back. All right, so now we're going to talk about alternating AC versus alternating current, AC current, and DC current, which is direct current. Now I got to be careful here. I have blown a lot of light bulbs because 1.5 volts down here, which is one battery, you go one more and you get 15 volts and that blows the light bulbs. Anyway, so the lowest I can go is 1.5. Okay, that's one battery, 1.5 batteries, 2 batteries, and that's as bright as I want to get because that little thing, that little filament is will break. Now you know that this one can go either direction, but let's put in a light emitting diode and see what happens again. All right, so I have a red light emitting diode, the same one we used before. There you go, it lights up. If I turn it around, I switch the leads, nothing. Okay, and again, I can do it this way to show you them changing from one to the other. The light comes on. All right. Now, down here, I have 2 light emitting diodes. Let's go ahead and put them together. We got them together, and let's go ahead and make sure I've got good connection on both of them. And this is there. Now notice the one is on. I think it's the green one there. I have bad color vision, so I'm sorry. Then I reverse it, and the yellow one comes on. Okay, now we're going to go up and use this device. This device actually does alternating current. Now I'm going to have to bring, the amplitude is actually the voltage. I bring that down, turn it on the back. You can see it's at a really, really high number of, by the way, it's a sine wave. So I'm going to bring this down to, say, 10 times, and I'm going to bring this even down to, 1 time a second. Now let's bring up the voltage. And you can see that it's alternating from one to the other. And if I increase the frequency, how often per second? So let's go up there 7 times a second. There's 3 times a second. And it's actually going back and forth because it's alternating. Now I could get this faster and you probably wouldn't even be able to see it because it'll just kind of blur. Okay? Well, there you go, alternating current. I'll end on me this time. Now, in your house you have alternating current, right? And that alternating current goes from into your house and back out. It's alternating back and forth 60 times a second. It's known as, a lot of times, 60 hertz. And if you listen to some things like lights and so fluorescent lights, they'll have what's called a 60 hertz hum. And okay, that's the frequency of the speed at which the electricity is flowing in and out of your house. Now, if the electricity is going in and out of your house, that means the electricity company, the power company, is actually not selling you electricity or electrons. They're not actually just going into your house or using them up. All they're doing is moving them. They're giving them power, and then the devices in your house can use that power. Computers and other devices use DC current, direct current. Your car actually has an alternator, which alternates back and forth. That's AC current, and you say when you plug in your phone into that, you have to have something that switches it over into DC current.